So on this one, again, I see that my exponent for my leading term here is double the middle one, right? I'm looking at the exponent. Even though they're fractions, 1/3 doubled is 2/3. So that's pretty good. And that tells me then that I can use U substitution instead of dealing with those fractional exponents. Oh. Well, another thing I noticed now that I take a better look at this is that the middle coefficient is 0. Even though they're showing minus 0 for some reason. That means this term really perhaps isn't so necessary. And that makes me think it could just be solved using exponents. But
4 times 4.
so I'm going to go through the process just so you can see it, even though we know the middle term is 0, and that's good. So here I would make U be p to the power of 1/3. And again, if I had squared both sides, then U squared, p to the power of 1/3 to the power of 2 would be like taking 1/3, multiplying that by the 2. So that's why p to the power of 2/3 is the same as U squared. Okay, so again, instead of using the base p, I'm going to use U instead. So p to the power of 2/3 now is U squared. And then p to the power of 1/3 is U, even though it's minus 0U. And then this would be minus 16. And that equals 0. Now at this point, well, I'm going to assume that you did not notice that 0U in the middle. So I'm going to work with it, okay? It's still factoring it's not even factoring by grouping. I'm just using the rule for factoring because my leading coefficient is still 1. And so I would be looking for two factors of negative 16 that add up to 0. If you want to say negative 0, that's fine as well. It doesn't matter. So negative 16, two factors that add up to 0 would be, like you said, 4 and negative 4, right? Now again, my variable here is U. So I've got a U plus 4 and also a U minus 4 there. And if we could get those two factors, those two binomials, to equal 0, that would be nice. So let's do that. So U plus 4, if I could make that equal to 0, that'd be nice. And we know, again, most students don't usually show this, but if you need to, because it helps, do it. So U could be negative 4 from the first one, but if you made U minus 4 equal 0, then solving for this one, you'd add 4 to both sides. And then you'd see U equals positive 4 as well. But now I need to go back and say, well, U actually was replaced with, it was replacing something else, which means that I need to go back and replace both of these U's with what it was originally, and that was p to the power of 1/3, both of them. So in other words, p to the power of 1/3 could equal negative 4, or p to the power of 1/3 could be positive 4. In my mind, I usually do this with, like if I do this in my head, I would think, I'm just going to put these two in root form. But the exponent's actually okay right here, because what I can do with those is to make it just a p, I would take this and cube it, right? So p to the power of 1/3 times 3 would be, 1/3 times 3 would be 1. And I really don't need that one. But if I do it to one side, I got to do the other side, right? So negative 4 to the power of 3 would be negative 64. And I can do the same thing over here. By the way, we would have done this to the power of 3 even if we had made it a root, a third root. But again, we get p equals 4 to the power of 3 is just positive 64. Now again, you can go back up here and replace those p's with 64 and raise them to the power of 2/3 or 1/3, and 1/3, I guess. And you would get an equation, both equations are equal to 0.